Assalamualaikum warahmatullahi wabarakatuh. My group will be presenting about the project 1, application of integration of work done in lifting objects. There are 4 group members in this group, which is me, Amal Isha, and the second presenter, Nur Ari Nadia, third presenter, Wan Anis Umaira, and last presenter, Filza Maisara. Do you know, in our daily life, many actions involve work, even if it goes unnoticed. So what is work? Work is a measure of the energy transferred to or from an object via the application of force along a displacement. For example, opening a door or lifting a bag demonstrate how energy is transferred through force. The concept of work helps to simplify how we understand physical effort in daily life and connect mathematical ideas with real-world experiences, which makes the concept easier to visualize and to understand. Building on this idea, the problem discussed further will focus on the work required to lift a bucket of water from ground by pulling a rope. And this provides a practical example of how the concept of work applies in real-life situations. The problem statement is a 5 kg bucket is lifted from the ground into the air by pulling in 20 meters of rope at a constant speed. The rope weighs 0.08 kg per meter, and how much work was spent lifting the bucket and rope. There are 3 main objectives of this problem, which is first, to determine how work is done in lifting a bucket and rope system. And then second, to calculate the total work required by applying integration to account for the varying mass of the rope. And then lastly is to verify and analyze the solution using mathematical derivation of both manual and computer-aided method. The application of integration. Lifting the bucket seems straightforward, but once the rope is included, the force is no longer the same throughout the motion. Instead of treating the rope as one heavy object, integration let us think of it as being made up of many tiny pieces. Each piece leaves a small distance and does a small amount of work. And by adding up all these small bits of work, we get the total work done in a way that matches what actually happens in real life. Thus, integration gives a practical way to calculate the total effort and energy needed, helping people design systems that are efficient, safe, and realistic.
Now, let's move on to the analytical method used to solve this problem. Before we look at the derivation, I would like to highlight a small update. While our initial report utilized a gravitational constant of 9.81 meter per second square, to standardize the value of G with our textbook and project requirements, we are using 9.8 for this calculation. Our model begins with 4 key physical parameters. The bucket mass is 5 kg, the rope density is 0.08 kg per meter, the total height is 20 meter, and as mentioned, gravity is set at 9.8 meter per second square. To calculate the work done, we first derive the total force function Fx. This is the sum of 2 components, the constant weight of the bucket, which is 49 Newton, and the weight of the hanging rope, which varies as the bucket is lifted. Combining this gives us our final force function Fx equals to 64.68 minus 0.784x. Finally, we apply the work energy principle through integration. By integrating our force function over the 20 meter displacement, we find the area under the curve. After evaluating the integral, the total work done is exactly 1136.8 joules. This analytical result serves as our theoretical benchmark, which we will now verify using math.
Next, I will explain our octave programming solution for this problem. First, we define the known values, which are the bucket mass M is 5 kg, the gravitational acceleration G is 9.8 meters per second squared, the well depth is 20 meters, which is the distance between the bucket and rope need to be lifted, defined as L in this calculation. Rho represents the rope's linear density, which is 0.08 kilograms per meter. The total work consists of two parts, which are the work required to lift the bucket and the work required to lift the rope. For the bucket, we use the formula W equal to mgl, which gives us 980 joules. For the rope, the force changes as the rope is lifted because the hanging length decreases. We model this using the function rho times g in bracket L minus x and evaluate the definite integral numerically using octave squared function. This gives a work value of 156.8 joules. Finally, we add the both components to obtain the total work W total equal to W bucket plus W rope. The octave output confirms our calculation, showing 980 joules for the bucket, 156.8 joules for the rope, and the total work of 1,136.8 joules. This demonstrates that octave provides an efficient and accurate way to solve real-world application involving definite integral and variable force.
As we come to the end of this project, I think it's important to take a step back and look at what we have actually accomplished. At first glance, integration may seem like just another mathematical technique we learn in class, but through this project, we saw how it can be used to solve a real-world problem, calculating the work required to lift heavy objects. What started as a theoretical concept became a practical engineering application. This shows that mathematics is much more than formulas on paper. It is a tool that helps us to understand and solve problems we encounter in the real world. Another valuable lesson from this project is the relationship between human understanding and technology. When we perform the calculation manually, we develop a deeper understanding of the concept and reasoning behind the solution. At the same time, computational tools allow us to verify our results and handle more complex calculation efficiently. Rather than replacing human thinking, technology enhances it. The combination of critical thinking and computational power enables us to solve problems more accurately and effectively than either could alone. Finally, this pursuit of knowledge has a deeper meaning beyond academics. In Surah Al-Mujadilah verse 11, which states, Allah will raise those who have believed among you and those who were given knowledge by degrees. This verse highlights that Allah subhanahu wa ta'ala elevates the status of people of faith and learning. Hence, it is important to continuously seek and apply knowledge in ways that benefit the society. For us as students, learning mathematics is not really about obtaining good grades or passing examinations. It is about fulfilling an amanah, a responsibility to develop our knowledge and use it wisely. By transforming mathematical theory into practical solution, we contribute, even in a small way, towards innovation, problem solving, and a betterment of our community. Thank you for your attention, and we hope this presentation has demonstrated how mathematics, technology, and knowledge can work together to create meaningful solutions. Wabillahi taufiq wa hidayah. Wassalamualaikum warahmatullahi wabarakatuh.